Difference of two squares factoring. Pause the video and try the warm-up. For warm-up A, we want to factor. So whenever you're trying to factor, you always want to factor out the greatest common factor first if one exists. So on warm-up A, let's see if we have a GCF. I'm pretty sure we do. So both terms have at least a b to the third, and both terms have at least an x squared. So I'm going to divide everything by the greatest common factor. And remember, your GCF should always be written out in the front. For the leftovers in the parentheses in the back, b to the third divided by b to the third cancels out to 1, and then x to the third divided by x squared. You're dividing like bases, so you subtract the exponents. 3 minus 2 is 1, so it would be x to the invisible 1, which is just x. In the second term, drag down the negative 4, and then careful, the x's and the b's don't line up, so make sure you're doing x squared divided by x squared, which cancels out to 1, and then b to the fifth divided by b to the third, you have to subtract your exponents. So 5 minus 3 is 2, so b squared. So then that would be your answer. For warm-up B, when we first look at that factoring problem, we look at all three terms, and there is no greatest common factor. So whenever you're trying to factor, always factor out a greatest common factor first if you see one. So since there's no GCF, when you look at this, you see three terms. So this is that basic trinomial factoring from yesterday. So we want to find two numbers that multiply to the number in the back, the negative 12, and then those same two numbers need to add up to the negative 4 in the middle. So 12 divided by 1 is 12, and since I'm trying to multiply to a negative number, that means one of my numbers has to be negative. Since I'm trying to add up to a negative number, that means my bigger number is going to be negative. So I'm going to put a negative sign on the 12. 1 plus negative 12 is negative 11. That doesn't work, so let me try the next number. Let's try 2. 12 divided by 2 is 6. I'm going to put the bigger number on the negative sign. 2 plus negative 6 is negative 4, so that works. So then we get ready to write our answer. So two sets of parentheses. The x squared got split into x and x, and then you have your two numbers that you found off to the side that work. So the 2 and the negative 6. If you were to multiply this out, you would get what you started with. On warm-up C, we are supposed to multiply that out, so I'm going to FOIL. First times first is x times x, which is x squared. Outside times outside is x times 4, which is 4x. Inside times inside is negative 4 times x, which is negative 4x. And then last times last is negative 4 times 4, which is negative 16. Don't forget to add your like terms in the middle. 4x plus negative 4x cancels out to 0. So then we're left with x squared minus 16. For warm-up D, I'll switch it up and do the box method. So I have x and 10 and x and negative 10. So x times x is x squared. X times 10 is 10x. X times negative 10 is negative 10x. And then 10 times negative 10 is negative 100. So I have my like terms of negative 10x and 10x that add up to 0. So the only thing left is x squared minus 100. So the new thing for today is called difference of two squares factoring, or sometimes you'll hear it called difference of two perfect squares factoring. So here are the steps you're going to go through. So step 1, you're going to factor out a greatest common factor if one exists. On this example problem of x squared minus 25, there is no GCF, so we can skip right over that step. The next 3 steps are us just making sure that this is the type of problem that we can actually use difference of two square factoring method on. So step 2 is the first term, which is x squared. Is that a perfect square? Yes, it is. Step 3 is the second term being subtracted from the first term. So basically just, is it a subtraction problem? Is there a minus sign in between the two terms? So yes, there is. Step 4, is the second term, 25, a perfect square? Yes, it is. So up to this point, we're just checking and making sure that we have two terms, they're being subtracted, both terms are perfect squares. Once you've identified all of that, now you're ready to actually do the factoring. So super easy. You just take the square root of the first term. So this is step 5. Take the square root of the first term and put it inside each set of parentheses in the front spot. So square root of x squared is x. So that goes there and there. Step 6, take the square root of the second term and put it inside each set of parentheses in the back spot. Notice you're going to ignore the minus sign. So you're not doing square root of negative 25, you're just doing square root of positive 25. So square root of 25 is 5, so put a 5 and a 5. And then the last step, step 7, just make sure that you do a plus in one of the sets of parentheses and a minus in the other set of parentheses. It doesn't matter which one's which. So your final answer for this one is x plus 5 times x minus 5, or it would be fine if you wrote it as x minus 5 times x plus 5. Either way would be fine. If you look over here where it says another way to think about it on the right, if you wanted to, you could change this difference of two perfect squares. You could change it into a basic trinomial by adding in this 0x term. So if you were doing it this way, you'd basically be saying, here, I'll do it right here. So you'd basically be saying what two numbers multiply to negative 25 and add to 0. So if you follow our same logic from our basic trinomial factoring lesson, I would do 25 divided by 1 is 25. I'm trying to multiply to a negative number, so one of those numbers would have to be negative. And since I'm adding up to 0, the two numbers I'm picking, they need to be the same number, just with opposite signs. So 1 and 25, that's not going to work. I'm just going to throw the negative sign on the 25 just so I remember that one of the numbers has to be negative. And that would not be negative 26, but negative 24. So then I would try 2. 25 divided by 2 is a decimal, so I wouldn't even bother writing it down. 25 divided by 3 is also a decimal. 25 divided by 4 is also a decimal. So then I get to 5. So 25 divided by 5 is 5. Make one negative, and there you go. So you would get ready to write your answer. So you would have x and x. That x squared got split into x and x. And then a 5 and a negative 5. So either way you think about it, it works. Most mathematicians do the shortcut method, which is what I went through first with the 7 steps. Most mathematicians would do it that way. Let's try a couple together, and then I would say pause the video and just do the rest of them, and then check the rest of the video. So let's do the first couple together, though. So on number 1, is there a GCF other than the number 1? No, there is not. Is it two terms? Yes. Is it subtraction? Yes. Are both terms perfect squares? Yes. So that means that this is a candidate for difference of two perfect squares factoring. So basically what I do is I get ready to write my answer. So it's going to be 2 sets of parentheses. Square root of x squared is x. Square root of 9 is 3. Make one positive, make one negative. Done. It's literally that easy. Let's do number 2 as well. So is there GCF? No. Is it subtraction? Yes. Is it only 2 terms? Yes. And are both terms perfect squares? Yes. So let me get ready to write my answer. Square root of x squared is x. And then square root of 121 is 11. Make one positive, make one negative. Done. Now notice, if we connect this back up to the warm-up, notice, warm-up C and D, the original problem on C, it was x minus 4 and x plus 4. When we multiplied it out, those middle x terms canceled out, and we got a difference of 2 perfect squares. For warm-up B, same concept. It was x plus 10 times x minus 10. When we multiplied it out, the middle x terms canceled out, and we got left with a difference of 2 perfect squares. So when you look down at 1 and 2, it should make sense to us that when we get our answers, you have basically the same factor twice, but one is positive and one is negative. At this point, why don't you pause the video and do 3 through 6. So on 3 through 6, when you look at all of these really quickly, none of them have a GCF. All of them are 2 terms, so they're all binomials, and they're all subtraction, and they all have perfect squares. So you just do a bunch of square rooting. So I'm going to go through this fairly quickly. So square root of x squared is x. Square root of 196 is 14. Make one positive, make one negative. For 4, square root of x squared is x. Square root of 4 is 2. Make one positive, make one negative. Done. Number 5, square root of x squared is x. Square root of 49 is 7. Make one positive, make one negative. Done. For number 6, square root of x squared is x. Square root of 64 is 8. Make one positive, make one negative. Easy peasy. All right, here's where we mix it up a little bit. So let's see here. Let's just do the first one, number 7. Is there a GCF other than 1? Yes. This is where it's a little bit different. We have a greatest common factor of 2. So we're going to divide out our greatest common factor like that. Then look at your leftovers in the parentheses. It's 2 terms. It's subtraction. Both terms are perfect squares. So what you're going to do is you're going to drag down your GCF of 2 in the front, and then you're going to do the new method that we've been doing on the last couple of problems. So square root of x squared is x. Square root of 16 is 4. Make one positive, make one negative. Done. And you do need to have that 2 out in the front. A lot of people forget that. Let me find one more that might be a little bit, or let me do 2 more that are a little extra challenging. Let's do 15. On number 15, is there a GCF other than 1? No. Is it subtraction? No. Is it a trinomial like we were doing yesterday? Is it 3 terms? No. So when you look at number 15, you can't do anything to that. So you would either say cannot be factored or not factorable. So you can't break that apart. That doesn't happen often, but we do give you some of those every once in a while. And then the last one I want to do together is number 18. So when we look at 18, is there a GCF other than 1? No. Is it subtracting? Is it subtraction? Yes. And then are both terms perfect squares? Yes. So this one just looks a little bit different because it has numbers and variables for both terms, but you're still going to treat it the same way. So when you look at 18, when you take the square root of 16x squared, the square root of 16 is 4, and the square root of x squared is x. So that first term in both sets of parentheses is 4x. In the back, square root of 25 is 5. Square root of y squared is y. And then make sure you do one positive, one negative, and then you're good to go. At this point, I would say pause the video, try the rest of them, and then unpause it, and I'll key the rest of it for you. So with number 8, is there a GCF other than 1? Yes. So we're going to divide that GCF of 3 out. So 3 comes out in front. And then looking at your leftovers in the parentheses, you have a difference of 2 perfect squares. So you're going to drag your 3 down in front, and then the square root of x squared is x. Square root of 9 is 3. make one positive, make one negative, done. On number 9, is there a GCF other than 1? Yes, it's a 7. So divide out 7 in the front. Looking at your leftovers in the parentheses, it's a difference of two perfect squares because it's subtraction and both of the terms are perfect squares. Drag down your 7 in front, and then square root of x squared is x. Square root of 100 is 10. Make one positive, make one negative. Number 10, is there a GCF other than 1? Yes, it's a 12. So divide out a 12. Looking at your leftovers in the parentheses, it's two terms, it's subtraction, both terms are perfect squares. So drag down your 12, and then get your two sets of parentheses. Square root of x squared is x. Square root of 1 is 1. Make one positive, make one negative, done. On number 11, is there a GCF other than 1? Yes. 11. So divide everything by 11. Looking at your leftovers in the parentheses in the back, it's two terms, it's subtraction, and both of the terms are perfect squares. So square root of x squared is x. Square root of 25 is 5. Make one positive, make one negative, done. Don't forget to drag down the GCF in the front. That's a very common mistake for students, is to forget to drag down that GCF in the front. Number 12, is there a GCF other than 1? Yes, the 6. So divide out 6. You get x squared minus 64. Looking at the leftovers in the parentheses, it's a difference of two perfect squares. So square root of x squared is x and x. Square root of 64 is 8 and 8. Make one positive, make one negative. On 13, is there a GCF other than 1? No. Is it subtraction? Yes. Is it only two terms? Is it a binomial? Yes. And are both terms perfect squares? Yes. So square root of 4x squared is 2x. Square root of 25 is 5. Make one positive, make one negative. Number 14, is there a GCF other than 1? No. Is it subtraction of two perfect squares? Yes. So square root of 16x squared is 4x. Square root of 49 is 7. Make one positive, make one negative. For 16, is there a GCF other than 1? No. Is it subtracting two perfect squares? Yes. So square root of 100x squared is 10x. Square root of 169 is 13. Make one positive, make one negative. 17, is there a GCF other than 1? No. Is it the difference of two perfect squares? Yes. So square root of 49x squared is 7x. Square root of 225 is 15. Make one positive, make one negative. 19, is there a GCF other than 1? Yes, a 4. So factor out a 4. And then looking at our leftovers in the parentheses, is that a difference of two perfect squares? Yes, it is. So drag down the 4 in front. Square root of x squared is x. Square root of 100 is 10. Make one positive, make one negative. And then last but not least, on 20, is there a GCF other than 1? No. Are you subtracting two perfect squares? Yes. So you're going to square root the first term. So square root of 49 is 7, square root of x squared is x. And then in the back, square root of 36 is 6, square root of y squared is y. Make one positive, make one negative, done.